So today I want to review a couple of concepts, and we talked about this stuff again on Thursday, but the idea of initial value and rate of change. So the first example we used on Thursday, I think was a gym membership. Is that true? Does that ring a bell? Let's take a look. I made the note. You think I'd remember? Yeah, so we talked about a gym membership, and what were the two types of memberships that you could have had?
One, they're like, drop in the members only.
Yeah, so there's one where you could just drop in. How did that work?
That if you were go, that like, if you go like once or twice, it's cheaper to do that.
Good, because what was the pay structure like? If you're just dropping in, how did you pay?
I think you paid like $3.
Yeah, it was like $3 per visit, right? And that was it. What about the members one? Did you still have to pay every visit?
Started off with, you have to pay like a flat fee of $4 then.
Yeah, that's right. Good. So very good. So we talked about how it had a flat fee of $4, but then every visit was a little bit cheaper. And so we've already kind of heard it, but if that's the kind of structure, if you're a gym member, like I am a gym member, which is to say you like to have the card to look at, but don't actually like going to the gym, which way of going makes sense for me?
Drop in,
right? Just pay per visit. Yeah, it's a little bit more expensive, but I'm not going often, so I don't have to pay that monthly fee. If you are, like trying out to be the next Arnold Schwarzenegger, Mr. Universe or Miss Universe, what kind of membership do you want? Yeah, you want to pay that monthly fee, right? And we saw that on the graph. So today we want to talk about those two ideas and use some of the language we would have used in grade 9, and we'll introduce you to some of the language we use a bit more in grade 10. But initial value and rate of change. So in the gym membership, let's talk about the one where I paid $4 at the start of the month no matter what, and then $2 at visit. There's two pieces of language we use, initial value and rate of change. In that example, what's the initial value? If I'm paying $4 a month no matter what, and then $2 per visit, which one's the initial value? They're $4. What's initial mean anyway? Yeah, initial means where we start. You think if you write your initials on something, what do you put?
your first starting to.
Yeah, like my initials are J-O, that's right. J is the first letter in Joseph. O is the first letter in Orlando. So those are my initials. So initial value means the starting value. It's the thing we start with. The initial of my first name is J. It's the first letter.
Your initials are Joe.
There you go. See, it's like they planned that whole thing. Unless you put my middle name and then the J-D-O, and that doesn't sound Jado. Not quite as lovely. But
John Doe.
my wife complains frequently that her initials are B-O. Which not great initials, right? That's weak. That's weak initials. And it doesn't get better because if you put her middle name in, it's B-E-O, which is still just B-O. So yeah, no matter what. So she's not a fan. Anyway, so I want to think about that here. An example. The cost C in dollars to park at Niagara Falls parking lot varies with time and hours. First of all, that's very mathy sounding. What's that mean? The cost in dollars to park at Niagara Falls parking lot varies with time. What's that mean?
You're paying for how long you're staying there.
Good, it's per hour. You're paying for how long you stay there. If I stay longer, what's going to happen to how much I have to pay?
It'll be expensive.
Yeah, it's going to be expensive. If I stay just a little bit, it should be cheap. Does that make sense?
Probably not. When you go in the fall,
That's true. That's true. These are real numbers from when I was there the other week. It's nice because it's like during the winter. If you went to that same parking lot in the middle of July, these numbers would be a lot bigger.
it'd probably be like double.
I bet they'd be more. I remember I used to manage a restaurant in the casino, and I didn't make great. I made okay money, but some days you'd get there and they'd want $20 for parking everywhere nearby. Well, I don't make enough money that's worth it for that. So I used to bike in all the time because it was just so expensive to park. Then I started.
Why should you have to pay when you work there?
Isn't that awful? My wife works out of a hospital in Grimsby. She has to pay $600 a year for parking. In Grimsby, can you imagine? And like for her, okay, whatever, she makes decent money, but like the cleaning staff would have to pay that same fee, or like, you know, like low-level nurses and stuff. That's a lot of money.
Fair.
No, it's not fair at all.
If you work there, they should give you a pass.
Don't you think? I always thought so.
Yeah. I really wish that they could get banned. Like, I can't wait to see the amount of deaths that is.
From what?
From those stupid e-bikes.
That's the next thing we speed drive. I got one this.
These are like the electrically powered bicycles,
Yeah,
right?
those are not going to be 2017. Oh, I hate it. Next day you see that person using it.
Okay.
So much, huh? I like that.
So there you go. Okay, so let's take a look at this. Looking at this table, this is my parking fees. So tell me about it. What can you tell me from this table? What
That
information
is
can you give?
why that if you're there for half an hour, it's $1.50.
Okay, so if I stay for half an hour, it costs me $1.50. A lot of money, I guess. So how much for an hour? $3. How much for an hour and a half?
You're interchangeable $1.50.
Hey, we're not, but if I were graphing this, would this make a straight line, do you think? Does it look like it's going up by a steady amount?
Yeah, it's going to buy
Yeah.
$1.50 every time.
Yeah, going up by $1.50 every half hour. So how much every hour? The first hour costs you how much? $3. Second hour costs us how much? $3 more, right? It doubled. Yeah. So that looks like it's going up by a straight rate. But what I want to talk about here is the initial value. What is the initial value here? What's the starting fee? $0. Does that make sense? So when you pull into a parking lot, they don't charge you anything for no time, right? If you pay it all, then you get a half hour's time. If you pay a bit more, you get an hour's time and so on. Does that make sense? If you went to one that had like just if you go to the airport and stuff, you can get a transponder where you don't have to get a ticket and put a ticket in, but you can just drive in. It knows you've driven in and driven out. If you had one like that, if you drove around, never found a parking spot, drove out, you didn't park at all, it wouldn't cost you anything. Does that make sense? So this has an initial value of 0. The initial value is $0. How did you know that? How did you find that? I know this seems simplistic, but it's good. It's good that we have it written down. How did you find that? Anyone? How did we know the initial value here was $0? Oh, we're still on long weekend.
Because it starts off with 0.
Yeah, okay, because the first number is 0, and it's not just 0 here, but it's 0 there. Yeah, let's keep in mind the initial value isn't necessarily the first number we see, but it's when your independent value is 0. When we have no x, how much y do we have? In this case, when we've spent no time, how much money? That's right. So when there is no x, and I know in this case we're actually using t, not x, but the principle holds. When there is no x, how much y? That's the initial value. And in this case, when there's no x, how much y is there? No y. So that's our initial value. Let's see if you remember this term from Thursday. Is that direct or partial variation? Or maybe from grade 9? Direct. Good. Yeah, you did do that in grade 9. How do you know? What's direct variation mean?
Direct is when it starts in 0, when initial is when it has like
Very good. Yeah, that's right. Yes. So direct variation is a line that starts at 0, 0. It's direct variation if only that rate per hour or rate per minute affects our cost. Good. Really good. Do you have something to write with? Can I get you something to write with? I'm going to do that. Does anyone else need something to write with? Because I like have pencils. I spent Eastdale money to get pencils. It's not even, you're not even putting me out. There you go. Everyone else is good? Yeah, great. Okay, so that one should be nice and easy. That's my only question. Let's look at the next one. Here we have the cost of rice depending on the mass in kilograms that you buy. Sorry? Whoa, hey, whoa, yeah, wow. How do we know that? Because we didn't have a table this time. How did we know that?
Because the line, or what do we call that line? Is there anything?
This line?
Yeah.
Well, that's the actual line we're interested in. So you can call it the line. That's exactly what it is.
Well, the line starts at 0.
You could also say the relationship starts at 0. That would be fair to say.
Well, anyways, it starts at 0, and there's like the fixed pocket is above 0.
That's right. If you look at this, if I buy 0 kilograms of rice, how much money does it cost me? $0. That means our initial value is $0. That makes sense, right? Most things, when we go to the grocery store, it's direct pricing, right? You pay for how much you get, and if you get nothing, it usually doesn't cost you anything, right? They don't charge you money just for pulling into the gas station, as we've just discussed. If you get there and fumble and discover you don't have your wallet, as long as you haven't pumped the gas yet, you can just drive away.
Just make sure the pump in the car.
Different story when you've pumped, different story when the pump is in the car. You want to avoid all of these things. Great, and just like the one above, if it starts at 0, 0, if there's no initial cost, we call that direct or partial. Very good. You know, I keep snagging these taxi questions off the internet, and they keep having such crazily unrealistic numbers. Man, it would be great if you could like go to New York City and get this taxi. This would really be.
Alfred had a taxi that was only charging 15 cents a kilometer in his question today, and I was thinking that's like a bargain.
Yeah, like that. That's even better than this.
One on Thursday, like, and it charged at 40 cents.
Yeah, it was super cheap. So I keep finding these questions, and that tells me that like. Well, what that tells me is that like some question probably got written in like 1942 for a textbook, and it's just been like, well, maybe not the 40s, but a while ago, and it's just been recycled ever since. Anyway, that's fine. So here we go. So let's look here. The cost of taking a taxi depends on the distance traveled. Different costs are shown at the table of values at the right. I want you to try and jot down what you think the initial value are and the direct and partial variations. No, I'll walk around and take one. I want you to write it down.
I did.
Good, I'm going to come and look. I just want to see. There's so few of you. It's nice. I can do this.
We didn't even do
Yeah,
it.
that's great.
That's
That's okay. Take a look. You got it. You're great. Can I see? Yeah, you're great. What do you think? What's the initial value? Okay, definitely partial. What's the initial value? When you start off, that's perfect. Okay, put it down. Yeah. I can't take a look. Like that. So let's talk about this. The initial value, let me start out. Okay, put that down for me. And is that correct? And beautiful, very good. Can I ask something? If I opened a window, letting a little light in, but also making it a little harder to see the screen, would anyone object? We're not writing a ton of writing today, and I feel a little gloomy. I don't know how you feel. You like the gloomy look? Well, I don't want to interfere with your love of gloom, but
It's too late, you know.
I feel better about that. I feel like I can like see some. I can like see a sky.
There you go.
I feel better. Okay.
Is it man?
Okay. So the first thing we talked about then is the starting value, the initial value, how much money it costs, and the next thing I want to talk about is the rate of change. And today we're going to look at rate of change different ways. You learned how to find rate of change a few different ways last year. Today we're going to talk about graphs. We're going to talk about finding the rate of change on a graph. And then, tomorrow we'll look at a few different ways that you also learn to do it. But here from Thursday, when we talked about this gym membership, if I was in the drop-in gym class, if I'm just dropping in whenever I want, what was my rate of change? $3 per visit. Good. Remember, a rate is always something per something. It's always $3 per visit, or it's 100 kilometers per hour, or it's $50 per gigabyte, or it's 20 students per class, or I don't know, so on and so forth. It's always a rate like that. And what about the members only, where we had a flat fee? What was the rate of change here? Yeah, so again, $2 per visit. Good. Every rate of change has a per. So I want to talk about how we could find that number if it wasn't given to you. In those situations, I told you, it's $2 per visit, it's $3 per visit. What if I just gave you a graph? Well, if we take a look at that again, it was dollars per visit. Let's go look at that graph from Thursday. You don't have to put there, I'll put it here. If you look at that graph, we put down below on the x-axis what? How many visits? Very good. And on the y-axis, we put cost in dollars. Good. And that rate of change, let's keep in mind, is dollars per visit. Really, what that rate of change is, one way of thinking about a rate of change is how does this y value change as the x value changes? In this case, how does the amount of money change as the number of visitors change? Does that make sense? As we change this one, how does this one change? So there's a way to calculate that. We can say that the rate of change is really just how much the y changes per how much the x changes. Does that make sense? Change in y per change in x. And you probably learned this in a slightly different phrase. Does this look familiar? Rise over run. Did you do that to death last year? Probably lots and lots of it. Really, when we say how much the y changes, we can look at that on a graph this way. So whenever we have a graph and we need to find the rate of change, we want to start out by picking good points that will work well to work with. Does anyone remember from last year what makes a good point if we're trying to pick a point on a graph? Like here? Is that on my line? Okay, so that doesn't work. And even if I went here, no, I'm not trying to be, see, that came off as ruder than I meant it. But even here, I would say that is a point. It's on the graph and it works. But it's not an easy point to read. What's a really easy point to read on this graph? Ah, yeah. Yeah, so come up and point. Show me one. Or show one here. Draw a point on a nice, clean, easy one that goes through that we can all see. Oh, you should find something that involves lots of jumping around with it. No, that's really good. That's good. Go. Okay, good. I like it. All right, art critic. Pick another good point for me. Anyone that works.
Critic.
Gotta make that dot real big. There we go.
They're definitely different styles. You've got like our Picasso here, maybe more of a Rembrandt over there. You know, realism. This one has like a nose oddly positioned on the side of its head, but that's cool. All right. So we picked two good points. Are there any other good points on here that we could have picked? I don't like any of these. I don't like any of these. Line on the 3. Here?
I don't know if it goes through.
That's okay. Show me.
Like in here.
Yeah.
So that is a point. It totally is a point. It's just tough to read. All I mean by that is this. So we know that the x value of this would be 3. What would the y value be? Like
2.5.
maybe 2.5, but we're kind of guessing, aren't we? Exactly.
It's halfway between 2 and 3.
Perfect. Is it exactly halfway between 2 and 3? I mean, I think you're probably right. It probably is. But do we know for sure? So, like I said, we want to pick points that we're absolutely sure about. And listen, he's not wrong. It's not wrong. I think it does, in fact, work out to be exactly halfway between 2 and 3. It is. So he would get the right answer. but we want to make our life a little easier. We want to pick nice points. Now, we said we have to measure how much the y changes. It goes up and down or left and right? Is this one y and that one x?
Oh, no, it's switched.
Yeah, it's switched. So this one is the y, that one's the x. Good. So if we want to know what the change is up and down, how do we typically measure that? On here. Going from this point to that point, how much does the y change? Well, what's the vertical distance between them? Yeah, 1, 2. Sorry? That's okay. I want you to follow along and draw on, please. We'll get you there. So what we can do is this. Imagine if we wanted to get from one point to the other by going just straight up and down and just straight left and right. So if I wanted to get from this first point, call it point 1 if you want, doesn't matter, up to point 2, how could I get there? Well, to get there, how far over would I have to go? Over by 2, and I'd have to go up by 3. Good. Good. Now, again, this 2, is that changing the x value or changing the y value? It's the change in x. Good. So that's the change in x. And what word do we use for change in x? Because it would get really cumbersome to keep writing that over again. Well, is that rising? That's running. Good. So we call the change in x the run. We call it that because it's intuitive. We can picture that here would be running 2 over, and it's also just shorter to right. What about this 3? Is that the x's or the y's changing? That's the rise for sure. That's the change in y. Yep. Good. Okay, it's a good question. What we want to know is this. To figure out the slope, to figure out the pitch, to figure out you could even think of it as an angle. One of the ways we can do it is to say, if I want to get from the first point to the second point, the line is a nice straight path between them. But we can think of it as how far over is that, and then how far up. Imagine you're using an Etch-a-Sketch. You ever draw on an Etch-a-Sketch? With the knobs? You ever use that? Those knobs let you go left or right and up or down. Does that make sense? So if you wanted to get from the first point to the second point, first you'd have to go over, then you'd have to go up. Does that make sense? And those are the numbers we want to know. How far over did we have to go? And we call that the run. And then how far up did we have to go? And we call that the rise.
Oh, okay.
And by the way, you see this a lot in construction. If you order roofs, if I phone Turkstra Lumber and I say, hey, I'm putting an addition on my house and I want to buy a roof, and I order the actual trusses from them, like the rafters and the roof, I will tell them the rise and the run. I'll tell them it's going to be this long a run and this big a rise. And then they make it annual like that. And we're going to talk about that, talk about how this comes up in construction. Does that make sense?
One thing that just confused me because
Yep.
I thought the dot would go down, right down here, right? And then you would create the triangle right there.
And you totally could have. The only thing with this point is now it would be 1, 2, and then how much? Like it could be 1, 2, and maybe who knows? You know what I mean?
Yeah.
And so we pick points that are nice. So what you did there totally works. Totally gives you the right answer. It's just hard to know exactly what that number is. So it's always easier if we pick big numbers like this. And then here's the deal. This is another one of those things. Remember we talked last week about like driving on the left side of the road versus driving on the right side of the road? Anything magical about driving on the right side of the road?
Nope.
No. Is it really important when you get in a car that you drive on the right side of the road? No? Here's the deal. If you're driving
alone, it doesn't matter.
if you're driving up and down your own driveway, does it matter? Not one bit. If you're driving on the QEW,
Of course.
yeah, it makes a big difference.
Well, I mean, you
right?
might end up in a ditch before you end up in the other lane.
Yeah.
So,
So very good. So it is really important And here's the deal, it's not because there's anything magical about being on the right side of the road. It's because we said, as a collective, as a society, this is a social contract. We said, hey, we're going to be the kind of people who, when we get in a car, everybody drives on the right side of the road. Nobody collides with one another. That's the idea. This is another one of those things. We define the rate of change as the rise over the run. Is there anything magical about putting rise on top and run on the bottom? Yes, I like that. It's intuitive. I like that a lot. Yeah, so I like that. So it has a bit of an intuitive to it. Rise over run sounds good. Maybe it sounds a little nicer than run over rise. That could be it. But there's nothing intrinsically too meaningful about that. When we get into science, there's some reasoning why we put one over top of the other. But mostly it's what we call a convention. It's just a way we do things. But just like driving on the correct side of the road, it's important. So, when we go to find the rate of change, it's very nice, by the way, just on a side note. It's looking very good. When we go to find the rate of change, it's always rise over run. So in this case, what is that? In this case, what's the rate of change? Rise over run. What goes on top then?
3.
3. Good. And what goes on the bottom?
2.
2. Good. If this was a roof I was ordering, I would phone Church for Lumber and say I need a 3/2 pitched roof. They actually don't even say the over. They just say like 3/2 pitch in construction because they just want to save that one little word, right? Keep it easy. I would get one at exactly that angle. It would rise 3 for every 2 that it runs. By the way, that's a pretty steep roof, isn't it? Not gonna make snow. Yeah, you're not gonna make snow build up on that roof. On the other hand, I wouldn't necessarily want to be up there hanging shingles. When I was a kid, I used to toboggan off my roof. My cousin Mike and I shouldn't be telling this story. Don't do this.
I have a story for you.
Just to be really clear. But I lived in like a bungalow. It was very low to the ground. It had a pretty shallow roof. It wasn't a 3/2 pitch, that's for sure. It was very, very shallow. No, and we used to spend hours shoveling all the snow in the backyard into a big pile under the roof, and then we would put a ladder up. And the funny thing is, now I'm terrified of heights. I would never do this as an adult. But as a kid, you're so stupid. And like the moment my parents would leave,
snow pile, like
well, I said once they leave, we'd get to work, and then they'd come home and go, "What did you do?" And I go, it was Mike's idea. Blame him. He made me do it. Oh yeah, no, for sure. But anyway, I wouldn't do that off this roof. That's for sure. That roof, it's very steep, right? It's a big pitch. Yeah, you'd build up a lot of speed. I would not feel good about that.
Forever ago in Crystal Beach, there was like a major snowstorm, and it was like apparently to the point where you just had to open your window and just like toboggan down, and not
Really?
that I was actually doing.
That's really crazy. Okay, can we try this next one? Why don't you try this next one? Pick a couple of good points, find the rise, find the run, and I'll come around and take a look. So I want you to do this one on the right. Pick a couple of good points, find the rise, find the run, and see if you can tell me what the slope is then.
So this works so good. So
You got it.
you do it like this.
That works great. Yep. Yeah, just draw your lines, tell me what the rise is, tell me what the run is, tell me what the slope is.
What picture? Did you take one? Or is he he's gonna use the one That's a 5. what is this? I don't need to lose. What is this? So there's an ant. Bro, every time. What is it? Where is it? Is that it?
I'll be
No,
told
that's
why,
not it.
bro.
I think it's on my wrist. Oh yeah, it is. There's the thing.
It looks like
Yeah.
5 times before you
This point is pretty rare. I love this one. There's another point that's good.
I killed a spider yesterday.
Yeah, I like that one. It was right here.
Roland, no, can you go to the bathroom?
It was a big one. You guys see it? No, I don't like it. Those things.
Go down there. Sorry. Like a minute, right? Like 3 minutes. Yeah, you bet. But be quick. Actually, can you do me a favor? Are you okay for 5 or come back quickly just because of the next point of the play? Hold on.
I know. This was like a baby trip. Carry and stuff.
Then why would you kill it?
Yeah, and that's okay. If those are the good points,
Oh, yeah.
those are the good points. Nothing wrong with that.
And then
She was like, spider yelled.
What are the points?
Oh, you're real scared.
So put paper towel.
And you really, you had so much time.
You keep going.
Come to the rise of the line. Come on.
So put a piece of paper towel over it and then stomp on it like until I get time.
Okay. Okay, let's look here. Miss Fortin, what'd you pick for points?
4.
So up here at 0, 4, 0 on the X, 4 on the Y. Yeah, and 5, 0, 5 on the X, 0 on the Y. Okay. What do I do next? That's it? I'm done. I've drawn my points. I go home. Tim, what'd you do next?
Why use the lines?
Nice, like this?
Yeah.
Great, then what'd you do?
And I counted the spaces.
Great, so down here, how many?
4.
4 down here? 1, 2, 3. Yep, no problem. That's okay. And what about up here? How many?
4.
That's 4. Very good. Okay. Now, what do we call this one on the x-axis? Changing down here.
That's the run.
That's the run. Good.
And going up to the right.
And that's the rise. Good.
That's the rise over the run.
Okay, and the rate of change? Okay, it equals rise over run. So what's it actually equal then? 4 over 5. Brilliant. Okay, we're almost there. We're almost ready to send you off to work, and I can leave you alone. I just have one question. So, look here. Look here. So these, which one makes a steeper roof, by the way? Which one's a steeper?
Pretty much everyone has a higher rise.
Very good, yeah. A bigger rise makes your roof steeper. A smaller rise makes your roof shallower. Good. So which one of these two?
The first one.
The first one's steeper because even though its rise is only 3, it rises 3 for every 2, right?
Yeah. And you can also look at your graph.
And you can look at the graph. Good. Now here's my question. Look here. This is key. So you guys did great. You drew your triangle. You picked good points. You found the rise. You found the run. You put rise over run. You told me the rate of change. Great. That's awesome. We're going to use it to do all kinds of actually fun and interesting applications over the next bunch of days.
Yeah.
But there is something different about these two lines. Something different about the rates of change. Something different about their slope, their pitch. However you want to describe it. What's different about them?
You're going different ways.
They're going different ways. All right. This one here. Let me ask you, this may seem kind of silly, but I'm going to explain this a few different ways. And the first way I'm going to explain this is the way I like to think about everything. Let's have a quick little question. There's only one right answer, and it's my right answer. What's the greatest video game of all time? No.
Mario Kart.
You're super close. Super Mario Brothers. Super Mario Brothers. It's just the greatest game of all time. It's perfect. It's perfectly designed. It teaches you to play itself. It's fun. Mario Kart's great. GTA 5 I've never played, but I assume it's great. But the greatest game of all time, hands down, no questions asked, Mario Brothers. Also lots of killing, just done by jumping on mushrooms. Seems somehow more wholesome. So,
That's one GTA gets hunted a bunch of people.
yeah, see, I just like to jump on the mushroom and then jump on like the Goomba and stuff. But anyway, so let's look here.
Build a car.
Okay. Now here's what I want to say. Shh. When you play Mario Brothers, how's it work? What way do you move?
Right side, left.
It's 2D, and it's almost one-dimensional, because really and truly, I move from this side of the screen to this side of the screen. Does that make sense?
Yeah, you're going.
I want you to imagine you're walking up this roof on Mario.
I fall off pretty quick.
Well, he's sturdy, that Mario. Is he going up? Is he going up the roof or down the roof? On this one, he's going up the roof. All right? And what about this one?
He's going down.
He's going down. Okay. Different teachers teach it different ways. I'm sure better teachers teach it better ways than I do. I like to think of it this way. Whenever I find the slope of a line looking at a graph, I worry about the numbers first. I look at the rise, then I look at the run, and then I ask myself this question. Is this line going up, or is it going down? Look at this key. It's like one of the big takeaways, big key concept. Going to come up a ton in this unit. So when I make my little triangle, I find my rise, I find my run, I get those numbers, and then I like to really intuit this. Does the line go up, or does the line go down? And when I ask myself that question, it's Super Mario Brother rules. Kenneth Dupuy, looking at me here. So when I look at the line, I want to imagine that I am playing Super Mario Brothers. Is this going up or down? So again, this one is going up. Okay, from grade 9 math, or from just your common sense, which one's going to be a positive slope? Which one is going to be a negative slope? What do you think? Okay, so you think this one is going to be a negative slope. And if that one's negative,
No, I changed my mind. Flip them.
well, I'm not gonna lie to you. I'm not gonna lie to you. I liked your first answer. I think you were good. I think you were right. And then I think I did the well you said, and then I think I psyched you out. True or false?
No, I looked and I realized that the first one was going. Yeah, no, I still like that answer.
Okay, so look, I'm going to tell you that this is true, that the first one is positive and that the second one is negative. And again,
Can I explain why I thought?
yeah, please.
All right, so the first one,
Mhm.
I thought it was negative because it started in the negative.
Ah, that's great.
It started in the negative and then got positive or more positive as it went up the graph.
Good.
Whereas the one on the right, it starts positive and then it goes into the negative.
So here's the great thing. Your answer is totally right. If we
Not the
were,
one you're looking for.
listen, yeah, but it's great. Your answer is totally right. If instead of slope, instead of the rate of change, you're really describing where it starts. What do we call where it starts? The initial value. So your answer was a great answer. It was just about the initial value. This has a negative initial value, and this has positive initial value. That's great. Those are good answers. We like those. But the slope, the rate of change, was the second half of both of those sentences you said. Right? In the second half, you said it starts in the negatives. Good. You just described the initial value. The initial value is negative. And then you said as it goes along, it gets more positive. Great. That's your answer. And I like both of them. The whole answer is great. So this one's positive because as we move along the line, the numbers are always getting more positive. Good. This one's negative because even though we start out positive, as we move along, the numbers get more negative. Good. So, again, different teachers teach it differently. If your grade 9 teacher taught you to do it in a different order and that made more sense to you, I encourage you to do that. There's a million ways to answer a math question. But look, we have to go back and look at these numbers. This 3/2, is it positive or negative? It's positive. I can leave it alone. But this 4/5, it's negative. And so I have to make it a negative number. Right? I have to make it a negative number because it's a negative slope. And what this really means is that this rise is actually negative, which when you look at the graph, does that make sense? Sure, because as we go over 5, are we really rising by 5? we're actually kind of falling by 5, aren't we? It's going down. So a negative values. Does that kind of make sense? But the way I suggest you look at it is count your rise, count your run, find the slope, and then take a step back and look at the whole big picture and say, is this increasing? Is this getting more positive over time? Or is it decreasing? Is it getting more negative over time? And that tells you if your slope is positive or negative. Okay, I want you to try the next couple examples and then on to the next page. And I will go around and help you, but you're on your own now. And you are welcome to put your headphones in. Gentlemen, the phones today, they're killing me. I finished. Are we in the next page, too? Oh, great, I can do the homework. Wow. Maybe we got the choice. The only thing I would say, it's the phone. Second thing, I would say, can you make that a simpler fraction? No. 12 over 4?
I don't want to.
But I think you can. What can you divide both top and bottom by? It's a right answer. That's 100% correct.
So 6 over.
Yeah, and 6 over 2, can you make that even simpler? What's 6 divided by 2? 3 over 1. And do we have to write a fraction over 1? No. So we could just say it is, well, 3 over 1 is just the same thing as saying? Yeah, good. So those are all right answers. But I would just say.
Stick with 12 over 4.
You like 12 over 4? No? I think you're doing stuff with it. No. Hey,
I'm just examining your.
What is this, bro? You failed, Julian.
Yeah.
You say I copied you and you
No,
copied
you
me.
don't take our
Well,
class.
so you're gonna handicap.
Well, you do take it.
How many times did I go up?
Oh,
You say
2.
you won this another class, or you won this distance?
1. Oh, it goes up 1? It goes up 1?
No.
Okay, well, it goes up normally.
It goes up 2.
Right.
Look at this.
No, 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 I put that because I got 3. Listen, I got,
You do seem
I
to have
got 2 over
flashy
4, and that's half. So I was simplifying.
I gotta run grab his own homework because they're flying. So I'll do that. I should run. And then how about the 5
Didn't finish.
I'll do that? Yeah. I want to see the end of it. Hey, gentlemen, you are quicker than I expected, so I'm gonna go grab your homework off the photocopy. I'll be right back.
Yes.
We have homework.
Well, listen, no reason you shouldn't be able to get done in class. You got lots of time. Lots of time. Wow. I hope you all got outside of it this weekend, by the way, because it was stunning, and it is still.
4 over 2 is time.
Oh, I was out. I was getting so bored sitting in the house. I'm like, all right, video games are getting really boring.
I hear ya.
I pretty much spent my whole
That's
life.
garbage. You don't-
Yeah, I did a class.
I literally
I love catching snakes. Did you catch any good ones?
What?
That's awesome. Where do you go? Just like from your house? Just yeah, that's awesome. My grandparents live out in Pelham. They have a big property. And they have like a ravine with like a little creek that runs through it, like not on their property, but next to their property. So we always go onto it, and you get the best snakes there. Real nice big ones. She has like a creek, like water flowing too.
Yeah, and it's actually.
Yes, you can write an equation that describes this river.
Yes.
Because there was a big fight and then we
Well, yeah.
So we're like, oh, we're gonna go for a walk. We saw this down where we had this cross.
Oh, you have
In the water.
This gives you this and
They can be vicious.
No, it doesn't.
They can be vicious.
okay, kids from board.
It's. What's like? Yeah, I can see that.
Why do you care? My boyfriend right next to it. No, you deleted the nickname. Wow, bro, I can't believe you. There you go, friend Matt. Let's go on his streak.
No, actually, I have 133. Well, there's on 133.
Who's that? His name? Take a look at this.
No.
Don't talk to you guys.
What do you do, bro?
Send.
Whoa.
Yeah, right over there.
There it is.
There you go.
Yeah.
Yeah. Yeah.
Yeah, go wrong.
It's texting soothing.
What? Where?
Why do you leave this? This pasta, bro. The Nazi symbol? Oh god. Did you remember that? What? Nazi symbol? What did you ever turn into before? Homework?
Yeah, now it's got like a point on it. This is not an assignment. It's just homework. It's just practice. I don't know what specific I've done, but I'm not marking this one. It's still some practice.
When you work on a math? Is that what you're doing? Timber. Oh, timber. Oh, you want to eat some stuff?
No, it's work.
What?
He doesn't.
I have to do it. It's a basic homework.
Yeah, I don't think I do want to see it for it's a funny idea.
It's Tim. I do kind of like.
Who is that?
It's Tim.
Oh, the
Oh,
other.
Tim. Man.
Okay.
You should probably like Tim. Okay, but it's fine. That's what. I think I have to do. Also,
What?
I'll make you a Timber too.
No.
Well, two Timbers.
No.
Good job, Nos. It's like 10. It's practice. I like it. This seems really hard on me. Okay, that's fine. What do you want?
Is this all the same?
Oh,
Yeah. Are you? It's not 1/1.
I was up late writing a grade on you actually, but
What is it?
What are you talking? Why are you making stuff up?
You know. You just do good close to work.
It's 1/2000. What?
We both messed up, bro.
It rises 2,000.
No, it starts at 1,000.
I don't watch much TV.
1,000.
I love Breaking Bad. No, I look at Breaking Bad.
We'll stop.
Adding an hour to my life.
Well, I cut down for the end of the.
So,
It's still me. I don't know. You're getting choked in those, bro.
Sorry.
All three of us are one.
I'm finding it vaguely hard to focus like that.
Yeah.
So, how far over is it? Up and down. But I use so that makes sense? Not space and wire, change next, up and down, change with left and right. Remember? I usually say that, I'll say up and down. But I got, what's the rate of change? Rory got these numbers, they look great, so it's great. Right, so in the next step. Really? I haven't seen sequels, so I can't imagine it's a sequel anyway. Okay, fair enough. Okay, no, we'll have to want to do that. Now, look. Let's include the.
No, you didn't put anything down. You skipped the answer.
Are you?
This one.
Arrow. That's not, are you?
Wait, in 2 seconds it goes 2,000 feet?
Good one. Yeah. I appreciate you fighting about math, actually a lot, but.
You can't do it. You can't.
What?
Help.
I think he meant so.
Oh,
You call that a positive.
Is that really wrong?
yes.
Well, all kinds of.
I'll have the balloon off the ground at 2 seconds. I think it goes 2 seconds.
That's a great question.
Is it exactly? I mean, that's,
Does the question say 2 seconds?
2
Yeah.
seconds.
2 is a very low number. That's a
2 seconds.
and the time.
I mean, you can do it.
Yeah, the time, it says 2 seconds, but the graph usually says time in 3 minutes.
That's too much.
So I literally want to minute, it says seconds.
So what fraction of a minute is a second?
B. 1B.
Look,
What fraction of a minute?
Shouldn't that be
How
2
many
minutes?
seconds are in a minute?
60.
60. So what fraction?
Yeah, I think you guys can do that. I think you can do it. I'm not gonna lie, I think I probably meant to put minutes on there.
Oh.
Actually, I didn't make this one, but I have a feeling that whoever made it meant to put minutes, but I think you can do this. I have faith.
So, he said he's trying to mess up.
Why don't you do both? A little bit extra work, it'll make you seem so clever.
My turn.
You know, it's about 1,000 feet in 1 minute.
And so it's not
I think they're about 100 a second.
Can you calculate that?
Yeah,
that makes sense. Find the numbers.
No, but not a pleasant number, it's 5.
Yeah, it's not. I suspect that falls into the category of myself. But we're brave, we're bold people. Yeah, absolutely. Especially what kind of things? Al, shutters.
That's not bad.
I have a really small calculator for my.
Maybe 9.
Intro to just an excess.
Yeah, 1 whole month.
That's what I'm having? Sure.
Didn't end up buying.
What'd you get though? I don't know. Let's just get this founded on the side. Hey guys, you want some?
I had to take out.
Definitely box.
The teacher gave it to me.
You put it in. Oh, you're disgusting. You like it? Is it good? Dawson, is it? Oh. Dawson, does it taste good? Hey, try the white one.
When do you have a red one?
Show the white one so it tastes like.
How much?
He ate a white one. He said it tastes
No,
good.
I.
He said it
I-
tastes good.
We'd actually finance this thing at 4.5.
I'll be so excited to see what it
That's some easy stuff.
I cube up half of a red one by now.
Why doesn't taste like anything?
It's so.
Why won't the have it?
You eat the red sauces? That's what you call extreme calories today. Eating something that's too open. That tastes nothing.
If I eat this, will you give me like $1?
Yeah.
You very
No,
happy
not
now.
one.
No.
So I like, yeah, you sound like you can't eventually.
I'll take one.
Who doesn't party makes you something no, maybe.
Remember in science? What? Yeah. And then you should have pop in your desk.
Oh yeah, with the vinegar and the egg.
Yeah.
I'm eating it.
It's good. It's huge. I'm not smelling like gummy bears. It's so hot. What's the fire? I mean, like what I looked at, that's how to do that.
Yeah, it really is. As long as you don't do it.
Yeah, it's like
Yeah. Yeah, I love it.
it's all right. That's so funny.
Better some, and I have done something a little sneaky. This is my grandfather's sneaky, and it's bottle. It's very small. Yeah. It's like accidental. It's like, I did for it. Exactly. The sneaky is like. Oh, is it?
It's
I go on my own so much money.
yeah, it's actually so much more.
Exactly.
My dad,
All my work done. Only thing I do on the phone.
it costs him to go to work.
I can write a PDF.
Not that weekend, but
I remember you talking about Korean. That's the zero one.
that, yeah. How it was like.
No.
Sushi's cheap.
I love it.
They don't. I do it before. It's not like Phillips car.
Yes,
I want like
So this thing, your process is quick.
But your hydro bill probably like $500 a month for TV and stuff. TV uses up more like.
If your hydro bill is $500, you're doing something wrong.
I don't know. It's not up a lot. 500 a month.
It's not TV.
I pay ours, like, last time I turned it on my TV.
You know, it's like, you just play that on your laptop now, man.
We get back from
Desktop.
desktop. Oh, you play Roblox for that? Then
Oh, yeah.
Roblox, Minecraft, Roblox.
You get to know this. I should spend that for Minecraft. Like the feeling on the phone. Nothing more like Minecraft. Yeah, I've got it. Don't you? You said you had it on phone. Oh, I've got it. How do you get it? That's what you said. Spending like $60. Yeah, I lost that guy.
Yeah. The graph is so wrong.
Bro, no, it's not. I didn't like that. All those are great CPs. I'll look at one. Actually, yeah, that's a bit more.
You go taking the keys.
The first one I know, right? What's the reason? That's good, and that's good. Great, so what's still left? How far was that? 1, 2, and exactly. That's good. Yeah, and then I believe with that. You don't like that.
I'm not doing this anymore.
I'm not doing that. But you want to practice a challenge. What should we do?
It's a practice.
Because I don't want to wrap it. So because it's a half, how do you make a half? Yeah. 5 double.
Yeah.
So if you double 2
You
half.
can do something like that.
There's 5 minutes left.
Yeah.
It's
3, 4.
5. That makes sense? You have 2
Nine.
nines in your pocket and 11.05 and 5. And if I'm gonna double 5, I also have double this.
Yeah.
12 more, you start.
Yeah, but you're not gonna do anything for the last 5 minutes. So 10 feet to your heads are
This is a completely
not for the
100% correct.
Totally right, that's the last, isn't it? No one will know.
Eating the food, getting all the food. In the 4 minutes. I guess I can use this class in 4 minutes. No, I can't.
You can't. 9 minutes.
Yeah.
9 minutes. You
I
can
feel there's like a million minutes. I need to do some like
do 4 minutes.
You got time.
Yeah.
I love my store. You got noodles and stuff. Nice.
Especially boyfriend, Matthew at school. You guys are fast food like that. Want to see it done? Want to see it? Right. Yeah, dude. I don't remember.
How are we doing, gentlemen?
Yeah, think about it.
No, you.
This one long. Oh, that's just
Work.
Look at this guy, he's not even done the first page over here.
Okay, I'll get to him. I'm not over there right now.
I don't understand
I'm
how
not
it's
telling me first.
Okay,
Let's talk.
3 minutes.
So this one here, this is kind of crazy. Let's pick 2 points. Let's say this point, and you can pick any one you want. You can have the point. Okay. Okay, so the run is easy. How about the run? Okay, so run is 7. What's the rise? You might, how much does this go up? But also, is the line going?
4, 14, 21.
Okay, this one is 7. Yeah, so the run is 7. Is it going up ahead?
Look at your 5.
So what's the rise? What's the number of the non-roll? Good. There you go. So now, what would the slope be? The slope would only one over what? Good, so it would be. Yeah, and rises in 7. So what's 0 divided by anything? By $0 divided between 7 people, everyone gets.
Oh, you actually have to do it.
So the
Yeah,
slope
you
of
have
a
to do
flat
it.
line like that
Yeah.
is, nobody gets nothing. And so you think about that. If I was building a house, and it's pitched like that, you would say it has a pitch. I thought it was just trying to. No, it actually wanted to talk about that. Oh, I never stopped this.
No. It's simple math. Let's look at 1 7.